Here is what to expect on my video. First, definition of central theorem. Second, definition of standard error of the mean. Third, formula for central limit theorem. Fourth, example and solution for central limit theorem. And the last one is additional activity for central limit theorem. So, on the first one, definition of central limit theorem. Central limit theorem states that the sampling distribution of the mean approaches a normal distribution as the sample size increases, regardless of the initial shape of the population distribution. If samples of size or n are randomly selected from a population, the sampling distribution of the sampling means will approach a normal distribution as the sample size larger. On the second one, definition of standard error of the mean. The standard error of the mean measures the degree of accuracy of the sample mean as an estimate of the population mean. It is also known as the standard deviation of the sampling distribution of the sampling mean, denoted by O subscript of x. On the formula, it is like an O with the subscript of x is equals to O over square root of n, where O is equals population standard deviation when n is equals to sample size. So on the third part, we have the formula for central limit theorem. When computing for the probability that I will take a value with a given range in a distribution of x, we use this formula. Z is equals to sample mean minus population mean over population standard deviation over square root of sample size, where x is equals to sample mean, u is equals to population mean, O is equals to population standard deviation, and n equals to sample size. On the part 4, we have the example and solution for central limit theorem. Here is the example. An electrical company claims that the average life of the bulbs it manufactures is 1,200 hours, with a standard deviation of 250 hours. If a random sample of 100 bulbs is chosen, what is the probability that the sample mean will be between 1,150 hours and 1,250 hours? Here is the step-by-step explanation of solution for the given problem. Step 1. Identify the parts of the problem. Here are the given. The population mean is equals to 1,200 hours, while the sample mean is equals to 1,150 and 1,250 hours. And the population standard deviation is equals to 250 hours, and the sample size is equals to 100 bulbs. The unknown is equals to P 1,150 is less than X is less than 1,250. On step 2, use the formula to find the z-score. On the first one, we have to use the first sample mean, which is the 1,150. So, we have to use the formula that are given on the part 3 of this video. So, 1,150 minus 1,200 over 250 over the square root of 100, which is equals to negative 2. On the second one, we have to use the second sample mean, which is 1,250. 1,250 minus 1,200 over 250 over square root of 100 is equals to positive 2. On step 3, use the z-table to look at the z-score you calculated in step 2. Z is equals to positive negative 2 has a corresponding area of 0.4772. On step 4, draw a graph and plot the z-score and its corresponding area. Then shade the part that you are looking for. P 1,150 is less than sample mean and is less than of 1,250. So we have this graph that is shaded on both negative 2 and positive 2. Since we are looking for the probability between 1,150 Hz and 1,250 Hz, the shaded part will be between negative 2 and positive 2. On step 5, we have to add the two z-score values. P 1,150 less than sample mean less than 1,250 is equals to 0.4772 plus 0.4772 is equals to 0.9544. On step 6, we have to convert the decimal in step 5 to a percentage. P 1150 is less than sample mean less than 1,250 is equals to 95.44%. Therefore, the probability of randomly selected 100 bulbs to have a sample mean between 1,150 Hz and 1,250 Hz is 95.44%. On this part 5, it is for the audience. The additional activity for central theorem. You have to try it yourself. Here's the given problem. There are 250 dogs at a dog show that weigh an average of 12 pounds with a standard deviation of 8 pounds. If 4 dogs are chosen at random, what is the probability that the average weight is greater than 8 pounds?